Hey there guys, welcome to the level 2 video for the Apprentice learners. So as I'm having, my teacher time with the novice learners, hopefully you're watching this video and to kind of figure out how to do problem set 2 and hopefully to approach it. Now, just some general recaps. Don't forget that exponents tell us how many times to multiply a number by itself. We call the base number, the base. And then the exponent, we also use the word power. So you may hear me say this, is 4 to the power of 3. We also have our formula chart given to us where a represents any real number. We have product of powers, which tells us what to do when we're multiplying exponents, which in this case, we add them. So 2 to the 5th power times 2 to the 3rd power is really 2 to the 8th power. Quotient of powers, which is the same thing as dividing exponents. So for example, 5 to the 7th power divided by 5 to the 2nd power. Well, we just subtract them. So 7 minus 2 is 5. Now, dividing exponents is the one we're going to be working with for problem set 2, and that's the important one. Notice it's different here. If we switch the numbers to 5 to the 2nd power over 5 to the 7th power, we get 1 over 5 to the 5th power. So notice we have the same numbers, we have the same variables, but the placement is different. Generally, the rule of thumb is the exponent stays in the place where you have the larger exponent. So in this case, since the larger exponent was on top, we would keep the base number, the 5, on top, subtract, and that will go on top. Now 5 to the 5th power over 1 to the 5th power would end up being just 5 to the 5th power. Anything divided by 1 is itself. Whereas here, since the 7 was a larger exponent, the 5 stays on bottom. But we'll do more examples here. And then the zero power law, which tells us that any number raised to the 0 power is 1. So for example, 34 raised to the 0 power is just 1. So here is problem set 1. Hopefully you worked on problem set 1 and were able to finish it on your own. Here's the answer key to problem set 1, column B. You got column A from the Ed puzzle, so you haven't watched the Ed puzzle yet, make sure to watch the Ed puzzle. And then here you're supposed to work on these on your own, so make sure you got these. Generally, don't forget that for problem set 1 is product of powers, which tell us when we're multiplying exponents, we're adding. So for example, here, you first have to add numbers that are like terms, so 9 times 3 is 27. X to the 3rd power times x to the 4th power, you just add the 3 and 4. X to the 3 plus 4 power is x to the 7th power. So check your answers with these, and we're going to begin with problem set 2. So problem set 2 combines two laws of exponents, which is the quotient and zero power law. And they're kind of going hand in hand, and we'll kind of see why. So generally what I want to do first is start off by showing you why the quotient law exists, and kind of why we use it as a shortcut. So if we expanded this out, r to the 3rd power is really telling us that we're multiplying r by itself 3 times, and r to the 5th power is telling us we're multiplying r by itself 5 times. 1, 2, 3, 4, 5. So notice here, we know whenever we're multiplying something by itself, or when we're dividing something by itself, it's 1. So in this case, no matter what the numbers are, r divided by r, since they're exact same, item, they cancel out. R divided by r is 1. Such as 2 divided by 2 is 1. Notice we have another r over r here, so that also becomes 1. And another r over r here, and that also becomes 1. So notice here, all these canceled out. However, we still have 2 r's remaining. Notice on the top, everything got kind of canceled out, and we kind of imagine these as 1s. 1 times 1 times 1 is just 1. So as we begin simplifying it, we get 1 over, notice we have r multiplied by itself 2 times on the bottom, r squared. Now the shortcut we could have taken was, first off, since our larger exponent is on bottom, notice 5th power is larger than the 3rd power, my base is going to stay on the bottom, and I'm going to put the 1 on the other side. Then you just subtract, okay? You'll do 5 minus 3. And then notice 5 minus 3 is 2. So we can do the shortcut so we don't have to do these each time, but I'll show you again, using example B, why we can use that shortcut. So this time we have h to the 5th power on top, so h multiplied by itself 5 times, h to the 3rd power on bottom, so h multiplied by itself 3 times. Well, once again, we end up with an h over h, which cancels out to 1, h over h cancels out to 1, and h over h, which cancels out to 1. This time, notice, my leftover h's are on top, and everything on bottom canceled out. So if everything on bottom canceled out, well, then I can put a 1 on bottom. 1 times 1 times 1 is just 1. However, this is going to give me 1 times 1 times 1 times h. Well, since h is being multiplied by itself 2 times, I can simplify it to h squared. Now, anything divided by 1 is itself. So I can still simplify this just to h squared. So that is what we get. Now notice, if I knew my shortcut and I had not expanded it out, and a lot of times you don't want to expand it out as you get into larger numbers. For example, here we can see we have z to the 12th power. Well, you don't want to write z 12 times. It gets kind of, long. So if you take the shortcut, you're going to look at your, quotient. You'll say, okay, which one has the larger exponent, top or bottom? Top. So my base is going to stay on top. Then you can subtract and say, okay, 5 minus 3. And then wherever the base didn't go is where you put the 1. Now, like we talked before, anything over 1 is itself, but notice we end up with a 5 minus 3, which is in fact 2. So for the rest of them, I'm going to be using the shortcut, but I did want to show you why the shortcut works, and then to see that if, the larger exponent is on bottom, your base stays on bottom. If the larger exponent is on top, your base stays on top. So going on to example C, we have two variables, but we'll still approach it relatively the same way. Now, when we always say, the rule for, dividing exponents with the same base. So you're kind of doing like terms. So right now we're going to focus on these two. Now notice we have two variables. This is really two problems in one. But we'll just, just deal with the x's right now. So I'm going to draw my division bar. And I'm going to ask myself, okay, which exponent is larger, 6 or 5? Well, I know 6 is larger. Since 6 is on top, my base of x is going to stay on top. Then I can write my 6 minus 5, since I know that when I'm dividing exponents, I'm really subtracting them. And then I'll have a 1 on the side that didn't have the base. Now I can move on to my y's. So I have y over 7. Now here, it doesn't really have a number written in, but if you remember from problem set 1, if you remember from the ed puzzle, when a variable is by itself, it has an implied power of 1. So this is really y to the power of 1. Well, now I can compare these two exponents. I know 7 is larger than 1. So that means my larger base is on bottom. So y is going to stay on bottom. The base of y is going to stay on bottom. Then I can do my 7 minus 1. And since 7 was on bottom, I bring the 1 on top. Now, you don't really have to write the times ones. Anything times 1 is itself, anything times 1 is itself, so you don't really have to include them, but I just wanted to show you what happens to our ones that we usually draw in. Now from here we can simplify. 6 minus 5 is 1, and then y minus 7 is 6, y to the 7 minus 1 is 6. Now you could also just rewrite this as x over y over 6, since we don't really write the implied power of 1. This is our answer for answer choice C. Going on to answer choice D, we'll notice here that, okay, so it looks like I have this problem right here. And now I have concrete numbers, not just variables. Well, we'll approach it the same way. We'll start, what color do I want to use? I'll use pink this time, with just the numbers. So you kind of treat it as if they're variables on their own. Now for this, 2 over 6, what you're going to ask yourself is, okay, are these numbers that I can reduce as a fraction? So you'll just look at it as the fraction 2 over 6. If you're not good with reducing fractions on your own, you can use Desmos or the in-class calculator, and I'll give you, a decimal answer, but if you click this button here, it turns into a fraction for you. And I believe it was 2 over 6, my bad. There we go. Notice it reduces to 1/3. So I can write 1/3. Okay, I simplified my whole numbers. Now I can go on to my x. So I have x to the 6th power and x to the 10th power. Well, what you're going to do is ask yourself, okay, where do I have my larger exponent? On bottom? Then my base is going to stay on bottom, my x stays on bottom, and I can do my 10 minus 6. Then from here I can simplify. 3x minus 6 is 4, and 1 just stayed on top. So it's 1 over 3 x to the 4th power. A few more to go, 3 more. So now I have E, F, and G. This is where it goes into my 0 power law, but I kind of want to show you what ends up happening. So x to the 3rd power we know is x times x times x, and x to the 3rd power, same thing as x times x times x. Notice, since I have x times x, I can reduce it to 1. So it ends up being 1 times 1 times 1. Well, this 1 times 1 times 1 on the top is just 1. 1 times 1 times 1 on the bottom is just 1. 1 divided by 1 is just 1. Now, if we had used the shortcut we knew earlier, we could have done x 3 minus 3, which is x to the 0 power. This is why anything to the 0 power is 1. You can think of it as we end up, subtracting our exponents, or you can think of it as they all end up canceling out. Here we can go straight to our shortcut. 4 to the 0 power is just 1. Anything to the 0 power is 1. And then here we kind of have a mixed bag of different things. So in this case, we have, two variables in here. So if you have two variables, similar to what we did before, we are going to, kind of do it here. Now what I want to change this problem slightly, I want to change, oh, there was my alarm. I want to change this to x to the 6th power on the bottom. I want to show you what happens. If you have x to the 6th power over x to the 6th power, it cancels out completely. So we don't have to worry about that. Now, if we keep moving on and we look at our y's, these don't cancel out. So we can keep going. So I can say, okay, well, my x is canceled out because I had x to the 6th power over x to the 6th power. That cancels out. Or if this one was, x to the 0 power, you would just keep the x to the 6th power. Which, since it looks like this one has 0 powers, let me change it slightly again. I'm going to change this to x to the 0 power on bottom. Just so it matches your g here that you have to do on your own. So in this case, you'll still approach it the same way. 6 is bigger than 0, so I'm going to keep the x on top. 6 minus 0 is just 6, so x to the 6 stays on top. The y is larger on bottom, so I'm going to keep y on bottom. 7 minus 4 is 3. This just reduces to x to the 6th power and y to the 3rd power. Now these look kind of complicated, but you can see if you take them as separate problems on their own and take it a step at a time, it's not that bad. So these are all examples for problem set 2. So you're going to, on your own, do problem set 2, column B, and then together we'll go over it. So try these on your own, see if you can solve them. They more or less correlate to the ones here. So this is a similar example here. This E from column A is similar to this E from column B. So kind of use these as examples. If you have questions, bring them to the teacher time that you'll have for the apprentice learners. And you'll have more time after we meet together, during our small group to keep working on this. But if you do have questions, make sure to ask them during your teacher time. Otherwise, you can rewatch the video, and if at the end of class you're still confused, please sign up for tutoring.